Hello, my name is Tom Dykes and this is my video interview. I'm really excited to be working with you guys. Little about me, I'm an aspiring stand-up comedian. I've been performing for 2.5 years. Stand-up doesn't pay the bills, so I've been working with Varsity Tutors as an SAT math and test prep tutor. I've been tutoring for over a decade and hope that my tutoring and teaching experience will allow me to give you a lesson here that is both informative and a little bit fun. So before I really get started here with the details, I want to tell you what are my main takeaways, because I think you're going to understand what I'm doing a little bit more if you understand why I'm doing it. First off, plug and chug is your friend. There's going to be a lot of situations where I don't know what's going on, and my first instinct is plug the simplest number into the algebra term I'm looking for, in this case x, x plus 2, x plus 4, to try to figure out what's going on. Secondly, learn to write pseudo-proofs. For those who haven't taken advanced calculus or real analysis, a proof is a set of logical statements that starts with a set of given premises, and you're trying to use them to reach a conclusion that the problem is asking you to reach. In this case, our conclusion is x, x plus 2, x plus 4, is that product divisible by 12? Finally, we need to test our premises for logical sufficiency. Logical sufficiency is essentially, does the premise have predictive power into the conclusion, which is, there are two ways that can happen. One is, both the premise and the conclusion are true, both true or both false every time. The premise could predict the conclusion in that they could both have the same Boolean value. Another way to have logical sufficiency, for opposites, if the premise has the opposite Boolean value as the conclusion for all possible values of x, that is also logical sufficiency. I know that's confusing if you haven't seen it before. We're going to go into detail later, but first, I need to talk about some fundamentals, about odd and even numbers. Now, some of you are telling me, Tom, odd and even numbers are simple. This is a waste of my time. Why are we doing this? To which I say, yes, you guys are smart. Yes, most of you understand this stuff. But some of you didn't know all of the details because you weren't taught right. Others of you have forgotten some of the details. I know you guys are smart. There are no dummies trying to get into business school. But at the same time, I know you guys are not omniscient. If you were, you wouldn't be taking this class. You'd be teaching it or curing cancer or something. So we need to cover these basics, even though they are basic, to make sure everybody knows them. Here are the basics for adding odd and even numbers. Here are the basics for multiplying odd and even numbers. And here's the basics for divisibility. I don't care what the quotient is. I want to know, is it divisible? So and notice 12 is even. So no odd number can be divided evenly by an even number. So I cannot divide an odd number by 12. Even divided by even can be divisible. So some even numbers are divisible by 12, some are not. But even numbers could work, odd numbers can't. So looking at the term, x plus 2, x plus 4, I'm a little lost. First step is to plug and chug. Plug in 1. 1 plus 2, 1 plus 4. 1 times 3 times 5 is 15. 15 is not divisible by 12. That is reducible. I'm not going to reduce it because I don't need to. I just know it's not divisible. 2 plus 2, 2 plus 4. 2 times 4 times 6. 2 times 6 is 12. 4 times 12 is divisible by 12. Notice how I'm doing this math. I am not doing it all the way. That is by design. Data sufficiency problems, they're confusing, they're long, they're arduous, and they're not really about arithmetic. They're about logic. So if you get caught in the arithmetic weeds, you will get exhausted and you won't get the problems done. So you need to learn how to do the math only to get to where you're trying to go. So now I plugged in 1 and 2. Let's try odd and even, okay? So odd plus even is 2, odd plus even is 4. From this rule, I know all of these terms are odd. From this rule, I know odd times odd is odd is odd. So in fact, for all odd values of x, we'll generate a term that is not divisible by 12 because 12 is even. Even plus even plus even, all even. Even is divisible by 2. I don't know yet if it's divisible by 12, but I know it could work. Odds can't work, evens might work. So now I have to figure out which evens work. And for that, I need to start talking about consecutive even integers. Tom, where did you get consecutive even integers from? Well, it isn't written in the problem, but let's look at some test numbers. Let's plug in x equals 2. 2, 4, 6. Those are consecutive even integers. X equals 4. 4 plus 2, 4 plus 4. 6 plus 2, 6 plus 4. So if I plug in even integers into the term, I will in fact get consecutive even integers. This is the rule in the abstract. It's confusing, so let's talk about it in the specific. If I have 3 integers and 2 of them are divisible by 2, and the third is divisible by 3, then their product will be divisible by 2 times 2 times 3 is 12. So let's talk about our consecutive even integers. Here, so for A and B, where do A and B come from? Well, they're consecutive even integers. All of the integers are even, so A and B will automatically be in the set because they're all divisible by 2. Where is C? This is a little trickier. So let's talk about the first set. In this set, C is 6. 6 is a multiple of 3. This has a 6, this has a 6, this has a 6. As soon as I lose a 6, I get a 12. 12 is a multiple of 3. C is now 12. I have 12, I have 12, I have 12. As soon as I lose 12, I get 18. As soon as I lose 18, I get 24. As soon as I lose 24, I get 30, 300, 3,000. Every set of 3 consecutive integers will have one of these circled numbers, a number that is a multiple of 3. C is always going to exist. So if one of the 3 numbers in the term is divisible by 3 and the other are divisible by 2, then their product, the term, is divisible by 2 times 2 times 3, which is 12. Conclusion, if x is odd, this is not divisible by 12. If x is even, this is divisible by 12. Good. Now we have to get into the answers. Logical sufficiency. Logical sufficiency for premise 1 can work 2 ways. If for all values of x, premise 1 false makes conclusion 2, premise 2 true makes conclusion false. If that's true for all x's, that's logical sufficiency. Or if they have the same, if they're both true or both false for all values of x, if those two are both true or both false for all values of x, that is also logical sufficiency. How do I test that? Plug and chug. Let's plug in 1 into premise 1. 1 squared plus 2 times 1 is 3. 3 is a multiple of 3. 1 makes the premise true and 1 is odd, the conclusion is false. So that's where logical sufficiency starts. Predict the opposite. F of 2 is 8. 2 makes premise 1 false. 2 makes the conclusion true. Logical sufficiency still holds. 3, f of 3 is 15. 15 is a multiple of 3. 3 makes premise 1 true, conclusion false because it's odd, so I'm still good. Uh-oh, f of 4 is 24. 2 plus 4 is 6. 6 is a multiple of 3. 24 is a multiple of 3. Therefore, premise 4 makes both of them true. And that's where it broke down. It lost the predictive ability. Everything before said, if I put in true, the conclusion is going to be false. But now this is saying I can put in true for premise 1 and the conclusion could be true or false. I lost logical sufficiency. Premise 1 is invalid. You cross out A and D on your answer sheet. Now we have to test premise 2 individually. It's much easier. F of 1, 3 times 1, 3. 3 is not a multiple of 2. For 1, premise 2 and the conclusion are both false. F of 2 is 6. 6 is a multiple of 2. Premise 2 and the conclusion are both true. F of 3 is 9. 9 is not a multiple of 3. 3 make both of them false. 4 times 3, 12 is a multiple of 2. 4 make them both true. I have predictive power. For all positive integers, premise 2 being false makes the conclusion false. Premise 2 being true makes the conclusion true. Premise 2 has predictive value. It makes everything valid. I circle B and I'm done. If this was invalid, then I test them together and I start looking at C. But before I do C, I have to test both of them individually. It's only when they both fail individually that I have to look at C or E. But premise 2 worked fine by itself. Answer is B. Conclusions. What are you guys going to have trouble with? What are you going to have to take away? For those of you who haven't taken an algebra class in a while, testing these functions with test numbers is going to be very difficult, particularly if you're used to doing the problems all the way. You have to learn how to do the problems part of the way. If you haven't seen logic, using truth tables to prove logical sufficiency, and especially the 2 different kinds of logical sufficiency, is going to be very challenging. But that's really, I think, the biggest component that got me from 50% on my first practice test in data sufficiency to 85-90% on the test. Thank you. This has been a fun lesson. I hope you enjoyed it too. Have a nice day.